Welcome back. What is the density of water at a depth where pressure is 80 atmosphere, given that its density at the surface is 1.03 into 103 kg? Water at the surface is under 1 atmosphere pressure. At the depth, the pressure is 80 atmosphere. Change in pressure is denoted by delta P equals 79 atmosphere. Bulk modulus of water B equals 2.2 into 10 to the power 9 Newton per meter square. So V equals minus P divided by delta V by V. So delta V by V is equals to minus P by B. If we put in the values of P and B, we get it to be minus 3.638 into 10 to the power minus 3. The negative sign signifies that for the same given mass, the volume has decreased. The density of water at the surface is rho, which is signified denoted by rho equals 1.03 into 10 to the power 3 kg per meter square meter cube. Now let the density at the given depth be rho dashed. Let a certain mass occupy V volume at the surface. So rho equals m by V, and rho dashed equals m by V plus delta V. Dividing the numerator and the denominator of RHS by capital V, we get this. Rho dashed equals small m divided by capital V, which is this, and if we divide capital V by V, it will come out as 1, and delta V divided by V. So if we put in the values of this, we get 1.034 into 10 cube kg per meter cube. The density of water at depth where pressure is 80 atmosphere is 1.034 into 10 cube kg per meter cube.